Hi, am I audible? Send me messages because I'm taking it for first time. Just wanted to know if my picture and voice is completely audible. I'd like to know. Am I audible? Send me messages. Yeah, of course, it is audible. The people are saying that it is audible. Fine. Okay, fine. Yeah. Now, this is Anil. I'm gonna take computer architecture for you guys. And when it comes to my profile, I finished my MTech in computer science, and I also did my MBA and MSc Mathematics from SV University. I've been in the GATE field for the past 12 years with various institutions. And when it comes to my teaching experience altogether, I do have 15 years of experience. I do teach a lot of subjects, many subjects, but here in this session, we're just going to cover just computer architecture. Yeah, when it comes to Ekeeda is the largest Indian brand for online courses, especially in the technical stream. When it comes to the technical stream, Ekeeda almost has the 10 different streams of engineering content. When it comes to the gate, recently Ekeeda has an initiative to provide an online training for the gate. Here, a student will get any branch student will get almost 500 hours of content, online content, recorded content, in addition to which he will also get an additional content of the live lectures in and around 400 to 500 hours till the time he joins, till the time he gives the gate. Okay, now let us dive into the topic of the computer architecture. Okay, but before that, let us introduce and send me hi. I just would like to see you guys. How many of you people are actually participating here? Am I completely audible and visual, first of all? Hello? 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 Yeah, yeah, yeah. Just give me time. Yeah. Now, let us start the computer architecture. In what way we are going to deal with this computer architecture? And when we talk about this computer architecture, let me tell you guys that this is something which is very different from the other subject, because here we are not doing any kind of a programming. Rather, we are not getting into the details of the operating systems or any kind of such stuff. But rather here, we are just designing the system. If you can stay focused, here just simply we are designing the system. Alright? Now, we need to think from the perspective of a designer. We are no more an end user. Rather, we need to think from the perspective of a designer. That means that we need to design the computer system entirely. Being an architectural guy, you are just expected to build a computer system. Okay. So here, first of all, remove all the stuff from your brains, whatever you learn, because altogether you're going to witness and understand the complete in-depth detail of the architecture right now. Okay. Now, but before we do that, let us understand some basic things before we get into the actual details. Okay. That is, when you talk about the architecture, first of all, we need to talk about from where the term computer architecture has been generated, has been invented, right? Okay, let me take the help of the history of the computer architecture. Okay, yeah. When you talk about architecture, first of all, we need to understand about a brief history of the computer system. Okay, here, initially, a computer system, all you people, as you know that, it just executes a program. Sir, what is the program? Anything is just nothing but a program. Whatever you do is just nothing but a program. We just sit before the computer system. When you type something, obviously a program will get executed. Either you move a mouse, or you type something, or you just listen to a song, or you play a game, or you watch a movie. Anything is just nothing but a program. This program will eventually get executed. So obviously, when you look at the computer system at a basic level, it just executes a program, nothing other than that. So first of all, we need to understand that in what way we are going to write the programs and in what way, where we are going to store the programs. This is the thing. Okay. If you are a programmer, you need to understand that a program is a set of instructions. A program is a combination and it's a collection of instructions. Right? Now, when you want to write a program, you need to understand several programming languages. Of course, we can render several programming languages like C, C++, Java, or whatever. Okay. Now, after you write the program, then there must be a storage provision where you can store the programs. I hope you got it. That is, initially when you look at the computer system at the basic architectural level, simply is just nothing but a program executing unit. Okay. Other than that, it does nothing. So if you want to design a computer system, being a designer, you need to understand that in what way the programs will be written by a programmers and where you can provide some provision to store all those programs. As it's shown here, a computer is all about executing the programs. Of course, a program is a set of instructions and a programmer is needed to write a program and thereby he will be able to execute the program. Okay. In the initial days of the computing system, of the programming, in the initial days of the programming, let me give you a brief history. That is, if you want to write a program in 1960s, in what way you are going to write the program? Thing is, at 1960s, in the earliest days of computing, there was no memory at all. When you look at your computer system, you can see that there is a memory. Okay, of course, there is a primary memory and there is a secondary memory. We will only talk about the primary memory, which is the main memory, because that is the only physical memory available to us. Okay, but here, when you were a programmer in 1960s, that computer system which was used in those days doesn't have any memory at all. Doesn't have any memory at all. Which means that a programmer, although he writes a program, there is no storage provision. Then, where a programmer can write a program? Simple. The thing is, at that time, the programmers used to have some punched cards. I know that, I think that you might have heard about a punched card. A punched card is a piece of a paper or a material on which some punches, the holes will be made. A pattern of holes will be made. Okay. If you want to write 100 lines of program, you need to collect as many punched cards as required to write your program. Okay. So once after you collect a vast number of cards, Then you start punching. You need to know in what pattern you are going to make the holes, because each and every pattern of holes is going to give you one instruction. Okay, a set of all those cards is just nothing but a program. So there, at that time, the memory was completely physical, meaning on a punched card. The only form of the memory that was available in 1960s was punched card. A programmer, if he's a programmer, just not enough to know how to write a program. You also need to know how to make a pattern of holes on a punched card. Okay, which means that it was a very difficult process to write a program in 1960s. It's a very difficult process. Okay, but there is something called one human architecture. What is one human architecture? After punched cards mechanism, in one human architecture systems, there is something called memory invented. This completely changes the entire look of the computer system, the entire feel of the computer system, the entire way the programs are executed in the computer system. This is all about one human architecture. Once again, initial days in 1960s, if you want to write a program, collect the punched cards, make a pattern of holes, write a program, after which you will be able to, feed all those cards to the system. Then the program will get executed. There is no storage provision at all. But after the invention of the one human architecture, there might be a doubt. Do you have any idea about one human architecture? What is one human architecture mean? A computer system with the memory was in the initial days called as a one human architecture. Okay, simple. If you want to understand, sir, what is this term one human architecture? It is not the biggest deal. The one human architecture is just nothing but a computer system with a provision of main memory. Okay, so there the memory was invented. If you are a programmer, after the invention of the one human architecture, just only the thing that you need to do is take a keyboard and type your program and store the program in the memory. This is what a one human architecture computer system is all about. Okay. I would like to know, do we have any doubts till here? Because we're going to discuss a lot of stuff here in this class. I would like to, understand if we have any doubts, if you guys have any doubts. Fine. So far, no doubts. Well and good. Fine. Once again, one human architecture meaning a computer system with a memory. If you are a programmer, the thing that you need to do is just you write the program by means of using a keyboard, type the program, store it into the memory. This is the fundamental rule of an one human architecture. What is the rule? If you want to execute a program, you need to store the program in the memory. You need to store the program in the memory. This is the thing. Unless you store the program in the main memory, there is no way you can execute it at all. If you fail to, you wrote a program and without any error, let us say that you wrote a program. But will you be able to execute without you store that in the memory? No, you can't. This is what the fundamental rule of the one human architecture. That is, once again, just remember this throughout your life, because being an architecture guy, we need to understand the important fact of the computer system, how it is going to execute a program. If you want to execute a program, that program must be residing in the main memory. Again, so what is main memory? Nothing. Main memory is a memory which is available on the CPU motherboard. Main memory is not your secondary memory. What is secondary memory? Okay, let us talk about the configuration of the computer systems. Your configuration of your computer system, when you look at, you can have a 4 GB or 8 GB of the memory, main memory, and you can also have 1 TB or 2 TB secondary memory. Some people, they do have they do need to understand the difference between main memory and the secondary memory. Of course, most of you guys, as you already know, main memory is physical, secondary memory is not physical. Now, what is main memory? The main memory is the memory chip which is available on the CPU motherboard, which means that that is the only memory available for a computer system. Okay, what is secondary memory? The secondary memory is a dump yard. Okay, now let us understand. In what way we gonna differentiate in between main memory and a secondary memory? Here, let us say I do have a CPU. This is my CPU. Okay, and the CPU is supported with something called a main memory, and also there is something called a secondary memory here. Okay, now this is, let me tell you that this is main memory and this is secondary memory. Okay, the difference between main memory and secondary memory is CPU will communicate with the main memory directly, but CPU cannot communicate with the secondary memory directly. Okay, because secondary memory is a peripheral device. When you look at the secondary memory, you need to think that this is a peripheral device. This is just nothing but a peripheral device. This is peripheral device. This is as like as your keyboard or mouse or any other peripheral device which is connected externally to the computer system. But when it comes to the main memory, this main memory is directly available. This main memory is directly available on your CPU motherboard. This main memory is directly available on CPU motherboard. That's the reason why this main memory is called as a physical memory, and the secondary memory cannot be considered as a memory at all. When a programmer writes a program, this program must be made available in the main memory only. Okay, once after the program has been loaded into the main memory, this program will be executed by the CPU. Okay, so which means that the basic fundamental rule of a program that is needed to be executed is, first of all, this program must be made available in main memory. This is the thing. Okay, yeah, initially we used a punched card, after which then there comes our main memory. In main memory, we are going to have all the programs residing. Okay, after the programs are loaded into the main memory, then the CPU will be able to execute this memory. Here, what's a program? You know that a program is a set of instructions. What's a program? Let me write it here. A program is a set of instructions, right? When you talk about an instruction, this instruction will also have a corresponding data. When you talk about an instruction, this instruction will also have a corresponding data. For an example, there is an instruction add a comma b, which means that a is a variable that is needed to be added to b. Okay, which means that this instruction will have two data elements. One is a, one more is b. One is a and one more is b. Okay, so here this main memory comprises of instructions and data. There is an instruction part and there is a data part. The instruction part is going to hold the instructions and the data part is going to hold the data element. This is the instruction part, this is the data part. The instruction part is going to hold the instructions and the data part is going to hold the data elements. More about instruction part and data part we are going to see in the upcoming classes. Any doubts so far? I'm waiting for you guys to ask me any doubts. First, you're fine. There are no doubts. So let me go ahead. So here, being a designer, what should we people design? What is the thing that is needed to be designed here? Now again, we are designing a computer system, aren't we? We are going to design a computer system. If you want to design a computer system, being an architectural guy, what is the thing that you need to design? Simple things. That is, first of all, we need to design a main memory, CPU and a main memory, because main memory is going to hold the programs and CPU is going to execute the programs. And then we start with the CPU, because you know that the CPU is the heart, right? The CPU is going to execute the programs. So what we do is, first we are going to design the CPU and followed by the memory. But when you talk about a CPU, is the CPU a single entity? No, CPU cannot be a single entity. Again, CPU is a collection of components, right? In CPU, there is something called a register set. There is something called a register set, and there is something called a control unit, and there is something called an ALU. Okay, so here when we design a CPU, first of all we need to independently design this register set and control unit and ALU. Altogether, collectively, we are going to design a CPU. All these things together will constitute something called a CPU. Now, in this session, we are going to focus on designing the register set. Okay, because CPU is going to hold three major components. One is register set, one more is control unit, and the third one is ALU. Okay, now first of all we understand about these components. What is the purpose of each and every component here, and then we go ahead with designing the things. The first thing that we're going to design in the CPU is a register set. So we need to understand what is a register set. What is the purpose of a register set? To be designed and maintained within a CPU. Okay. Now understand register set. Okay. When you talk about a register set, you know that the computer system is going to execute the programs, right? What's a program? A program is a set of instructions. A program is just nothing but a set of instructions. Okay. And all these instructions are available in main memory. All these instructions are available in main memory. The instructions are available in here, memory. Now, when the programs are getting executed, one by one, these instructions will be transferred to the CPU. As any program is getting executed, one by one, these instructions must be fetched by the CPU. Thereby, it will be able to execute. Okay, for that reason, we should be able to provide some intermediate storage provision within the CPU to access these instructions one by one. Okay, let us say there is a first instruction here. Let me write it here. There is a first instruction, there is a second instruction, there is a third instruction, there is a fourth instruction. It is a program is a set of instructions, but where those are available? These are available only in the main memory. But when you want to execute, you require a CPU, right? When CPU executes this, it is going to access these instructions one by one. It calls instruction number 1. When instruction 1 goes to the CPU, it should be able to sit within the CPU. for a stipulated time as long as it gets executed. Okay, so for that reason, we need to have a storage provision within the CPU which is going to hold the instructions concurrently as long as they get executed. So for that reason, we are going to design a register set. We're going to design a register set. Okay, this register set gives a provision to store the instructions within the CPU. And the programs are in the main memory. CPU execute the program executing instructions one by one. When an instruction executes, CPU should accommodate inside. Hence, a register set is used, right? Then, after we design the register set, then we go for a control unit. What is the control unit? The control unit is going to synchronize all the activities of the system. The control unit is just going to synchronize all the activities of the system. Rather, at this time point, at this point of period, we can think a control unit as a controller of the total system. That is, when you talk about a computer system, the computer system is going to hold a CPU. In CPU, we're going to have a register set, we're going to have a control unit and an ALU. Of course, a main memory is available within the CPU, within the computer system. So this control unit is going to synchronize all these components. Okay. This controls the total activities of the system. Okay. Now, the important thing you need to understand in a control unit is this control unit is going to hold and master the system clock. As you people already know that the system will have a clock, right? The system always will have a clock. Every computer system will be provided with a clock. Every computer system is provided with a clock. This clock will be handled by the control unit. The control unit is going to take the help of the clock and synchronize and controls the activities of the total system. Okay. Then, what is ALU? When it comes to the ALU is going to perform arithmetic and logical operations. When it comes to the ALU, it is going to perform arithmetic and logical operations. You know what are the different arithmetic operations? What are the logical operations? As a computer system is going to execute the programs, and the programs are going to be a set of instructions. Each and every instruction, when it gets executed, it is going to perform either an arithmetic operation or a logical operation. This can be done in the ALU. Okay, this ALU can perform either an arithmetic operation or a logical operations. Okay, the instruction will perform an ALU operation. Okay, but there is some exception. Some instructions won't perform any ALU operation. But during the course of this computer architecture, you are going to understand the different types of instructions. Okay, now let us talk about the design of the register set straight away. Okay, so far what we learned, if you can have a look at, we are going to design the computer system. We're going to design the computer system. The computer system is a collection of a CPU and a main memory and a secondary memory. When you want to design, you must be able to design a CPU in addition to the main memory. The CPU is going to hold a register set, control unit and ALU. But when it comes to the main memory, it is going to hold all the programs. So what to design? Initially, we need to design the CPU. When you design the CPU, you need to design three entities. The first one is a register set, second one is a control unit, and the third one is an ALU. Why do we require a register set? Every time when an instruction is being executed, the instruction will come into the CPU and will sit in the CPU for a while. That means that we should be able to accommodate an instruction within the CPU as long as it is getting executed. So if you want to execute any instruction, first of all, that instruction must be available within the register set of the CPU. So for that, we need to design a register set. The next thing is the control unit. What is the control unit? The control unit is a total controller of a system. This control unit is going to use a clock. Okay, by using a clock in a timely manner, the control unit is going to hold all the activities of the system. Okay, control unit is going to master all the activities of the system. Finally, when it comes to the ALU is going to perform either an arithmetic operation or a logical operation. Okay, as you know that register set is going to provide a basic storage provision within the CPU. Every time when you execute instruction, that instruction with an associated data should be residing within the CPU. Okay. Yeah. Now let us concentrate on designing a register set. Yeah. Let us start with this register set design. Okay. Now stay focused. So far we talked about some fundamentals, how the program is going to get residing in the computer system, and find what way it is going to get executed. And now we'll focus on the register set design. Stay focused here. Let us not get into the details already unless we are completely comfortable with the things what we have already. That is, what we learned so far is needed to be completely understood. Here we are no more an end user. Here we are simply the designers. You can't think from the point of view of an end user at all. You need to think from the point of view of a designer only. Okay. So for that reason, you never think from the point of view of a designer, of a end user or a programmer. We are designing the system. As we know that CPU design is involved in register design and control unit design and an ALU design. We will start with this register design. Okay. Now, when you talk about register design, in what way we need to design? Simple, the registers. Let us stay focused. Yeah. There might be a question asked when I talk about a registers. Sir, what is a register? Please let me know. Some people they may ask me, sir, what is a register? Okay. If you want to understand a register, first of all you need to understand something called a flip-flop. If you want to understand about a register, you should be able to understand about a flip-flop. A flip-flop is a binary cell which can hold a 0 or 1. One single flip-flop can hold either a 0 or a 1 at any point of period. You know that the computer system is going to hold only a collection of zeros and ones. Okay, eventually when it comes to the main memory or the internal architecture of the computer system, it supports only two digits, two binary digits. One is a 0 and one is a 1. Okay, so if you want to store either a 0 or 1, you do require a flip-flop. A flip-flop can store a 0 or a 1 at a time. A single flip-flop can hold only one digit. It could be either a 0 or 1. There are several flip-flops. Okay, there are several flip-flops such as RS flip-flop or JK flip-flop or a D flip-flop or a T flip-flop. I am not talking about the architecture of the flip-flops. I am just giving you an idea that we do have several kinds of flip-flops. depends on the application, we can choose one of these flip-flops. If you can understand, only the basic flip-flop, rather the mother flip-flop of all the flip-flops is RS flip-flop. Okay, this can be considered as mother of all the flip-flops because either it's a JK flip-flop or a D flip-flop or a T flip-flop are just derived from RS flip-flop. Okay, forget about it. When it comes to a flip-flop, it can store either 0 or 1 at a time. Only one at a time. Okay, which means that if you want to store some numbers, you do require a collection of flip-flops. Okay, now here exactly the definition of a register you have seen. That is, a register is a set of flip-flops. A register is a set of flip-flops. If you want to store an 8-bit number, you require a collection of 8 flip-flops together. You require a collection of 8 flip-flops together. One, two, three, four, five, six, seven, 8. Okay. Now you can clearly see this is a register. Okay. Eventually, if you can understand, a register is a collection of flip-flops. Simple. What we need to do is we need to design this register set. Okay. So if you want to design a register set, I can have 3 options. I can either go for a single accumulator organization, or a general register organization, or a stack organization. But try to understand, when you talk about a stack organization, altogether it's a different ball game. It is completely different from single accumulator organization and a general register organization. It might be too technical to discuss about the labels of single accumulator or general register stack organization already. It is very early to discuss about this because these are, when it comes to designing a register set, the essential thing that you need to understand is the CPU should hold several registers at a time. Okay, the way you need to organize is different. I mean, can be of different types. One is single accumulator. Okay, in this way you can organize these registers. Second one is general register. In general register way also you can organize this register. And the third one is a stack organization. This stack is common for every computer system. Okay, let me tell you. You do have an 8086 at your home. You do have an 8085 at your home. You do have something called i7 at your home. i5, i9, anything. In every computer system, there will be a stack. Okay, stack is common. Either you go for a single accumulator organization or a general register organization. Stack is common. Stack is completely common. So what we do is, while we design a register set, first of all, we'll take single accumulator organization into account. We will design our register set with a single accumulator organization. Okay, once after we understand a single accumulator organization, then general register organization and stack organization will be a cakewalk. Okay, then general register organization and stack organization is just a cakewalk. Yeah. Now I got live streaming to the chat. So far it was off. Okay, now I hope you got a complete idea about what we're going to design here. Initially, we're going to design a single accumulator organization. Alright, let us stay focused. We are going to design a computer system with a single accumulator organization. Okay. Yeah. Let me design the single accumulator organization registers. We are designing a register set. Pan tab is not working properly. In which we're going to take single accumulator organization. Okay, so now we are going to design a single accumulator organization computer system. Okay, we're going to understand several different registers which are available in single accumulator organization. Okay, the basic registers that are available in single accumulator organizations are as follows. The first one is something called a PC, which is called a program counter. Second thing is something called an address register, and the third one is something called an instruction register, and the fourth one is something called a data register. Fifth one is something called is an accumulator. Okay, this is an important one. Okay, sixth one is something called a temporary register. Seventh one is something called an input register, and eighth one is something called an output register. Okay, these are the registers that are available in a single accumulator organization. Let us understand what are these registers are all about. What are these registers up to? Okay, what is single accumulator? What is program counter, address register, instruction register, data register, accumulator, temporary register, input register, and output register. Let us stay focused and understand. Okay, let us see the purpose. You do not think about any other thing other than the purpose of each and every register as of now. Okay, let us have a look at program counter. When it comes to the program counter is going to hold the address of the next instruction. Address of next instruction. The program counter is going to hold the address of the next. Just a minute. Program counter is going to hold the address of the next instruction. Address register. We will talk about address register after some time. Instruction register. That instruction register is going to hold the current instruction which is getting executed. Okay. The current instruction that is getting executed concurrently. Okay. Data register is going to hold the current data element. That is, let us say that when you execute an instruction, you know that we do require an operand. Okay. So at this point of period, you need to understand that the data register is going to hold the operand of the current instruction. Okay, we will understand clearly. I am going to give you a clear picture in what way these instructions are going to hold the data what I am explaining you right now. Okay, the accumulator. What is this accumulator? This accumulator is going to hold the output of every instruction. The accumulator is going to hold the output of every instruction. The temporary register. The temporary register is going to hold the temporary data elements. What is a temporary data element? Sometimes when you write a program, there might be some temporary variables. Those variables, when they are needed, will be called into the temporary register. Okay, so temporary register is going to hold some temporary variables whenever those are needed to execute within the program. Input register. What is an input register? When you type something by using a keyboard, a character will get generated, right? When you type something by using a keyboard, a character will get generated. That generated character will get transferred to the input register. Okay, so input register is going to hold the inputs that are generated by the input devices by the user. And the output register. What is the output register? The output register is going to hold the outputs that are needed to be sent to the peripheral devices. You got me already? Yes, exactly. What is output register? when you want to give an output, let us say you want to take a printout. When you want to take a printout, this printout must be a set of characters, right? When you want to take a printout, some set of characters will have to get transferred to the printer, right? So all these characters initially one by one will get transferred to the output register. From output register to the printer, the characters will get transferred. Okay, the thing that is the thing. Once again, the what you call all these registers. The purpose of all these registers is when it comes to the program counter. Yeah, here you can see that there are several registers. In that, you just identify something called an instruction register. Here, this is an instruction register. You can clearly see. This instruction register can also be called as a program counter, which is going to hold the address of the next instruction. Sorry, this is program register. Program register. Sorry. Okay. This program register is going to hold the address of the next instruction. PC will have generally two names: program counter or instruction pointer. This could be called either as a program counter or an instruction pointer. This cannot be called as a program register. In this PPT, it is given wrong. But you need to understand this is a program counter. Okay, what is the program counter? Program counter is going to hold the address part of the next instruction. I'm going to show it here. Okay, here let us say this 23rd address holds the current instruction. Let us say, okay, CPU is currently executing the instruction which is at the 23rd address. There is a current instruction. Okay, which means that the CPU is executing 23rd instruction concurrently. At that time, the program counter is going to hold 24, which means that the program counter is going to hold the address part of the next instruction. Alright? That is exactly what the program counter is all about. The program counter is going to hold the address part of the next instruction. Okay, I will talk about this address register later. Then there is something called instruction register. This instruction register is going to hold the current instruction that is being executed concurrently. That is what about the instruction register. Data register. This data register is going to hold the memory operand. The data register is going to hold the memory operand. The current instruction which is getting executed requires an operand. That operand will be held by the data register. Okay. Accumulator. What is accumulator? I told you people that accumulator is going to hold every output. Only you remember this, not any other thing. Accumulator is going to hold the output of every instruction. Okay, for an example, I'll show it here. Okay, I do have several 100 instructions, let us say. 100 altogether, my program has a set of 100 instructions. Okay, when first instruction gets executed in this set of 100 instructions, there is an accumulator in the CPU that will get updated. Okay, after executing the first instruction, the accumulator value is something X. Okay, means that X is the output of the first instruction. Then after executing the second instruction, this accumulator will get updated again because second instruction also gets executed. So accumulator will get updated. Let us say after executing the second instruction, the contents of the accumulator is Y, meaning after executing the first two instructions, the partial output of your program is Y. I hope you got the point exactly. That means that every time when an instruction is getting executed, the output of the instruction is going to be held within the accumulator. Okay. So if you want to see a partial output at the end of any instruction, you just watch the contents of the accumulator, which will give you the partial output. Finally, if you want to see the complete output of a program, after executing all the instruction in current example, after executing the total 100 instructions, You just watch the contents of the accumulator. Accumulator is going to provide you the final output. Once again, what do you mean by accumulator? Accumulator is going to hold the partial output during the execution of any instruction, but it is going to give you the final output after executing the final 100 instruction within your program. Okay, so this is what the accumulator is all about. Okay, yeah. The next thing is, as I told you, that temporary register. When it comes to the temporary register, it holds the temporary data elements. Okay, and we enhance more about the temporary registers once after we get a complete gist of all the registers. Okay, because let me tell you something, that is, when you execute a program, this program may require some temporary variables. I'll tell you what it is. You execute a C program or a Java program, but when you try to pass the parameters in a function to a function, arguments to a function, what is the scope of this temporary variables? This temporary variable scope, which are used to pass the parameters to a function, are in which the scope is pretty much limited. What is the scope? The scope is just in and around just 4 to 5 lines, right? When the scope of a variable is pretty much confined to a localized area of a program, this particular variable will be coming and residing in a temporary registers, such as parameters, passing the parameters, arguments to a function. Okay, so all these temporary variables will come and reside in the temporary register whenever those are needed. Okay, as you already know that input register, the input register is going to hold the inputs from the input devices, and the output register is going to hold the outputs which are going to be sent to the peripheral devices. Yeah, now let us talk about an address register. Okay, so far do you have any doubts? Let us have some doubt session. Do you have any doubts so far? Video is not visible. I'm just working it on this bit. Yeah, I think it is clear right now. Any doubts so far? Fine. Um, I think there are no doubts here. Fine. If that is the case, if that is the case, let me go and talk about address register. Okay. Let me give you some fundamental idea about an address register. Okay. There is CPU. Okay. And there is main memory. Okay. Now, CPU, where the programs are available, the programs are just available in the main memory. If you can stay focused, the programs are just available in the main memory, right? Yeah. But the CPU is going to get the instructions or data from main memory only. For that, CPU need to send an address to the memory in which the content can be accessed. For an example, CPU want to access the content which is available in 20th address. CPU want to access the content which is available in 20th address. Okay, so under 20th address, let us say that there is a content. CPU want to access the content which is available at 20th address. For that, CPU should send an address reference 20 to the main memory. For that reason, CPU employs something called an address register. This address register will be given the addresses that are needed to be located within the main memory. Okay, every time when CPU wants to locate an address, immediately that address will be transferred to the address register. This address register is a mediator to locate the contents, to locate the addresses within the main memory. In this case, CPU want to search for an address. CPU want to search for an address 20. CPU will do it only by using the address register. This address register is a mediator who takes the addresses from the CPU and goes to the main memory and finds out where this address is. For an example, address register is like a postman. Okay, he is going to collect the address and he is going to locate the exact location of this particular address. In this case, 20 is given to address register. That address register is going to hold 20 and he will be able to locate 20 here. So thereby, he will be able to, collect the data which is available in 20. So address register is the register which is essentially used to send the addresses and locate them within the main memory by the CPU. Whenever CPU wants to refer to an address, immediately that address will be transferred to the address register. This is what the address register is all about. So now let us understand all the registers in a nutshell. As I already told you, these are the registers. The first one is the data register. Second one is an address register. Third one is an accumulator. Instruction. The order might be different. The order that I told you people is program counter, address register, instruction register, data register, accumulator, temporary register, input register, and output register. Order might be different, but the purpose of each and every register is clearly classified and separated. For example, program counter holds only the address part of the next instruction, but when it comes to the address register is going to hold any address that is needed to be located in the main memory. When it comes to the instruction register is going to hold the current instruction which is going to get executed currently. Okay, what is the data register? Data register is going to hold the current data operand which is needed to execute the current instruction. Accumulator, of course, as you know that accumulator is going to hold the outputs. Okay, temporary register, the temporary register is going to hold the temporary variables. Input register, the input register is going to take the inputs, whereas the output register is going to send the outputs to the peripheral devices. Okay, that's it for this session. Just I want to know any doubts you have so far regarding the session regarding the topic that is completed within the session about the registers within the single accumulator organization. Okay. You're fine. If there is no doubt, I'm summarizing this.